All right, welcome to this video, which is going to be a lesson on lines of symmetry as well as rotational symmetry. I'm packing this all into one lesson because it's got a lot of similarities inside each of those outcomes, and they do really represent stuff that is very common amongst symmetry, which we've talked a little bit about in the past. In other lessons, I have gone over this when it comes to reflections, but now we're going to take a look at lines of symmetry as well as rotational symmetry. The first example that I want to go over in this lesson here is taking a look at a picture. Okay, and this one happens to be a picture of the Winnipeg Jets. A logo, it's slightly modified to make it actually work in this case, but we're going to take a look at how many lines of symmetry does this logo have. If you look at it, you're looking for where is there a line that we can reflect both sides on each other so that they are equal to each other. Okay, so where one side is equal to the other side, where it's like a mirror image of it. This logo right here has a line of symmetry that goes right up the middle like that. You'll notice that the left-hand side and the right-hand side of this logo are identical. Okay, at least they're a mirror image of each other. It's not the same image just copied and pasted. It's flipped so that they are a mirror image of each other. Now, if you look at this, do you see any other lines of symmetry? No? You're looking hard, you can't see another one? You're right, this one doesn't actually have any more. This one has one line of symmetry in it, and this is an example here of what we call vertical symmetry. There's a vertical line that means up and down, straight up and down. There's a vertical line of symmetry that is in this logo, and that's it. That's the only one we have. Let's take a look at another hockey logo. Okay, we're going to look now at the logo of the Boston Bruins. Is there any lines of symmetry in this logo? Ignore the little registered trademark on the bottom there. There is one, yeah. It goes right there through the middle. Okay, well, I mean, they always go through the middle, but it goes through the middle as a horizontal line of symmetry. Okay, and that's the only one that this logo has. And like I just mentioned, it is an example of horizontal symmetry. Okay, it's a horizontal line. We could have vertical lines, we could have horizontal lines. Now, there could also be slanted lines as well, and we'll get into an example of that a little bit later. But these are two examples of lines of symmetry that we could have. These ones both have a single line of symmetry. Let's look at this logo here. Now, I don't have the name of this logo. I found it, and it works really well for the situation that we're doing right here. But does this one have any symmetry, any lines of symmetry? No, it doesn't. Okay, this shape does not have any line symmetry. Okay, there's nothing that no line we could put in here where each side is a mirror image, and part of that has to do with both those purple and I believe that's a green color, depending on what it looks like on your screen. But the purple and the green, they are not symmetrical shapes, and so we can't put a line through any of them. This one is, and there's three of them, so that doesn't help either. This one does not have any rotational symmetry, or sorry, it doesn't have any line symmetry, but it does have rotational symmetry. Okay, and so that's something that we can take a look at. Rotational symmetry is a bit different than line symmetry. So this is that second thing that we're going to look at here. So line symmetry, is there a line that goes through it, a reflection? Rotational symmetry means, can we take a spot right in the middle, or like a point in the middle, and rotate it around like this? Oh, sorry, not quite. We're going to rotate it around on the axis like this. There we go. Notice how it rotated a certain amount and then it ended up exactly on the right spot, right? So it rotated to exactly the same look on there. It has rotational symmetry. Okay, this shape is going to reflect every time it turns a third of the way around. So it could go like 3 times and always match up with the same thing. And that would be it's kind of the way that it works rotationally. And we'll look at more examples as we get a little bit farther along. What that means is that it has an order of rotation of 3. That's what we call order rotation. And it also means that if we have a circle that's 360 degrees, that's one full rotation. Every 120 degrees, or 360 divided by 3, every 120 degrees, it's going to match up to its original shape. So it has an order of rotation of 3, and the angle of rotation is 120 degrees. So this is something that we can use to represent our shapes. Some of them will have a larger number of rotational symmetry. Other ones will have a very small number of rotational symmetry, which again we'll take a look at as we get into more examples. So there, another rotation. Perfect. And we can do that 3 times. So here's just a little bit of a diagram that shows us exactly the different ways of rotation. So we have this like plus sign, and you'll notice that there's that red line that goes up there. It's just to show you kind of positioning of the first position. When we drop it down, I'm going the other way here. Okay, we drop it down. That's one rotation, and then it goes to the bottom. That's the second rotation, and it comes up to the left-hand side, which is the third rotation, and then it goes all the way back up to the original, which is a fourth rotation. So this one here has a rotational, it's able to rotate 4 times. It's got an order of rotation of 4, and its angle of rotation would be 90 degrees because every 90 degrees it matches up with the original shape again. Okay, so this is what we're talking about when we mention rotational symmetry. Now, when we're going through these, we're going to be looking at a number of different shapes, and we're going to be looking at some different pictures and trying to figure out, do they have rotational or do they have line symmetry, and what is the value of that? So let's start with the first one here, and that is a general square. Let's draw the lines of symmetry for the shape. Does it have horizontal or vertical symmetry? And on the second side, does it have rotational symmetry? Now gladly pause the video here and try it yourself, see if you can get the answer, and then start it back up as and then I'll go through the answer with you. So let's take a look at the answer to this one here. I'm going to put a square there on the bottom, nice bright yellow square, and let's take a look at the lines of symmetry. First of all, this square has a vertical line of symmetry, okay, which I'm hoping all of you got. Okay, the left and the right hand sides are equal to each other. It also has a horizontal line of symmetry, okay, which is that flat line because the top and the bottom are also reflections of each other. And being a square, it has these slanted lines of symmetry as well. Okay, so it has 4 lines of symmetry in it. This shape has vertical, horizontal, as well as what we call oblique symmetry, which are the slanted lines. So oblique symmetry is what we would call it when it has a slanted line of symmetry. Now, some shapes, depending on the way they're oriented, will not have vertical or horizontal symmetry, but would have oblique symmetry in them. Now, so again, sorry, there are 4 lines of symmetry. Now, does it have rotational symmetry? Well, yes, we can rotate it 1, 2, 3, 4 times around that axis. So in other words, this one's going to have an order of rotation of 4, okay, because it can go 4 times around, or it match it up 4 times in one rotation. And that means its angle of rotation is 360 degrees divided by 4, which is 90 degrees. So that gives us our angle of rotation. All right, what about a rectangle? Again, give it a shot, try the lines of symmetry as well as rotational symmetry, and then I'll go through the answer in just a minute. Let's take a look at the answer. So I'm going to again draw out my nice bright yellow rectangle, and we're going to look at lines of symmetry. I'm going to start, does it have vertical symmetry? You betcha it does, yep. Left and right hand sides are identical. Horizontal symmetry, top and bottom are identical. Oblique symmetry, not in this one. Okay, we can't go corner to corner because if we were to take a rectangular piece of paper, fold it from corner to corner, it would not match up perfectly. That's one way to think about it when you're looking at oblique symmetry. It's something that my students have often had a problem with. They think that there should be a line of oblique symmetry from corner to corner because it worked with a square, but with a rectangle it does not because it doesn't have the equal sides. So this one only has the 2 lines of symmetry. It has both vertical and horizontal, and like I said, 2 lines of symmetry. Now, does it have rotational symmetry? Yes, it does. Okay, we can rotate this twice. Okay, it has an order of rotation of 2, so we can rotate it 1 time around so that it matches up kind of that horizontal shape again, and then the second time around, it's going to come back to the original shape. And that tells us that it has an angle of rotation of 180 degrees. Sorry, I didn't have the animation of this one flipping around. You're just going to have to trust me on that, or try it yourself when it comes to a rectangle. Next shape we're going to take a look at is a pentagon. Now, again, does it have line symmetry? And does it have rotational symmetry? And what are the values for that? Okay, give it a shot on your own, pause the video, and then come back and we'll check and see if we have the right answers. The pentagon, okay, does have vertical symmetry, but does not have horizontal symmetry. It does also have oblique symmetry. These are the 5 lines of symmetry that the pentagon has. Okay, so there's that vertical piece up and down, and then every point to middle of a side happens to be a line of symmetry because it has an odd number of sides. It's being a pentagon, 5 sides. And so that's going to be we're going to have 5 lines of symmetry. Again, like I said, it's got vertical and oblique, but no horizontal in this one. Now the rotational part, we could rotate this one 5 times. Every time that point on the top rotates around to the point on the side, okay, on every side, it's going to match up with the original shape. And so it has an order of rotation of 5, and 360 divided by 5 is 72 degrees. So we have an angle of rotation of 72 degrees. Now, most of these like normal shapes, like any polygon shape, like pentagon, hexagon, and so on and so forth, is going to have symmetry in both the way it's in both rotation and linear or line symmetry. All right, now we have a different shape. We have an L. Okay, again, give this a shot, try it out. Does it have symmetry, both line and rotational? And I'll come back in a minute and we'll figure out if we got the same answers. Okay, this one here, is there line symmetry? No, there's no line symmetry. There's no line that we could put through here to figure out to make it so it matches on the left and the right. This shape just does not work for that. Okay, there are 0 lines of symmetry in this shape. It's just the way it is. Okay, not all shapes have symmetry. Some do, some don't. Now, does it have rotational symmetry? The only way we're going to match up with the original in this case here is if we turn it all the way around. And so it's going to take one full rotation and match up one time with that final result. And so it has an order of rotation of 1. Okay, this is every shape will have an order of rotation of 1 for sure. Some might have more. And so the angle of rotation is 360 degrees. Really what this is saying is this shape has 0 symmetry. Not at all. That's just the way that this shape is. All right, let's try this one. Does this one have line symmetry? And does it have rotational symmetry? Take a look and we'll come back in a minute. All right, let's take a look at this shape. What you'll notice about this shape is it doesn't have nice even sides. It kind of does have like 3 equal parts. If you want to think of like that line and then a little jog in that line. And so those are all even, which is going to help us with rotational symmetry. But this one here has no line symmetry. There's no line we could put through so that, again, we could fold it in half and get the exact same value. This would be actually a really good example if I were to print it off and have you cut it out and try to fold it in half. You're going to notice that there's no symmetry in this shape. So again, 0 lines of symmetry. Now, what about order of rotation? Okay, is there rotational symmetry? Well, if you were to take and put your finger, let's say you had this on a piece of paper, put your finger right on the middle point and then turn it around, okay, you're going to notice that that top little flat piece is going to match up with the one on the right-hand side. And then it's going to match up again with the one kind of on that bottom left-hand side. And so this one is actually going to match up 3 times. It has an order of rotation of 3 and an angle of rotation of 120. Now, it can sometimes be tough to visualize this, but it's important that we take a look and see if we can figure out what kind of rotation or symmetry these shapes might have. Okay, that's part of what this lesson is all about. All right, let's look at now an example of a flag. Does anybody recognize this flag? It's Jamaica, yeah. Okay, it's a great flag. It has great symmetry in it as well. And it has a little bit of false symmetry in it, which I'll go through in a little bit as well. But I'd like you to take a look and say, does this have rotational symmetry? And does it have line symmetry as well? And we'll come back in a minute and determine if we got it correct. Okay, let's take a look at our answer. I'm going to put it on here. Does this have line symmetry? Well, we're going to start off with the vertical line. Yes, the left and right hand sides are exact, so they are symmetrical. Okay, there is that line symmetry. There is also a horizontal line of symmetry, so we can use that. There are those two lines. There is no oblique, and I say that because it does kind of look like there might be, but it doesn't. Again, it's a rectangle, so it does not work. The only flags that would work for oblique symmetry are ones that are square, and there's not a lot of those out there. Gladly try to figure out one that might be if you know your flags of the world. This one here only has the two lines. It has vertical and horizontal symmetry, but this flag does in fact have that kind of symmetry where not every flag does. Now, does it have rotational symmetry? Well, if we were to turn it a full 180 degrees, it matches the original. Yay, we got it. Yeah, and then we're going to turn it another 180 degrees. Okay, so again, halfway around. And we're going to notice that this one has an order of rotation of 180 degrees, which is great for angle, sort of rotational symmetry. Okay, that is looking again a brief little synopsis and look at both line symmetry as well as rotational symmetry. Time to go take a look at some of the questions that you might have been given, whether in your assignment or whether this is for pleasure. I hope that you enjoy, and all the best as you take a look at your math.